Welcome back. In the previous video about the finite element model using weighted residual methods, we introduced the procedure that we use for assembling the equations of the domain. The assembling of the equations of the domain involved using the data we produced for each element, which we called earlier the element equation. After assembling, we found out that we could not really solve the problem for the unknown values, and we need to apply some boundary conditions in order to be able to solve the problem. For doing that, we will introduce an example. The simple example here, we are already handling a bar element. Let's assume that we are fixing one side. Fixing one side in a bar element means that the value of u1 will be known. In this case, fixing it means that u1 will be 0. It doesn't move, only allowing u2 and u3 to move. So the equations, the three equations of motion, will involve a 0 value here. Everything multiplied by that 0 will disappear. If we separate this equation, this set of equation into two equations, the first one involves the unknown values, u2 and u3. There is, remember, there is a column here coming from those two numbers. This column is useless because it's going to be multiplied by 0 anyway, so we kind of ignored it. And the other set of equations comes from the first row, minus 1 times u2 and 0 times u3 equals f1 and p1. Now you can find an inverse to this matrix. 2 minus 1 minus 1, 1 is invertible, an invertible matrix. If you invert it, you can multiply it by the right-hand side vector. P2 and P3 are known values, F11 and F22, and all these F's are known from the inputs of the problem, so you actually end up with a solution for U2 and U3. This is called the primary equations, a set of equations that can be solved into to yield the values of the unknown variables U2 and U3. Now you have U1. All the three values of the displacements in this problem are known. We can use that into what's called the auxiliary equations. The auxiliary equations will give us the reaction force. Here, P1 will actually be the reaction at the support of the bar. Similarly, if we used another example of a fixed bar, you will have u1 and u3 equal to 0, which when substituted into the equations will give us the primary equation, only a single equation, with u2 as the unknown variable, and the auxiliary equations will yield the reaction forces at P1 and P3. Of course, here we might be talking quickly without specific numbers. We will, in the coming video, first summarize the finite element procedure. Then we will present 4 different examples, step by step, how to solve them or how to build the problem and solve it. And one of the examples will involve generating a new element with a varying cross-section properties. But let's start with a summary of the finite element procedure in the next video.